So X equals the quantity, or I should say number of items, produced and sold. And I should mention there's an assumption throughout this entire thing that anything that gets produced also gets sold. So like all of this would fall apart if you produce like 1,000 items and nobody bought any of them, then this whole model falls apart, because then your profit isn't really based on, like, your profit is different because you don't earn all the revenue you expected to from everything that you made, right? So like we have to assume that the number produced is equal to the number sold in order for any of this to actually work. So this is going to be the input of all of the functions. So we are now going to write, so the basic idea is that we write 4 functions based on the quantity inputted, or the quantity produced and sold. So we've already talked about price, right? So this is going to be lowercase p of x. To confuse matters, there are 2 p of x's. One is uppercase and one is lowercase. The way that I tell the difference is just the size of my x, right? So if you like kind of put x on the same level as like the round part of the p, then it looks like a lowercase p. But do something so it doesn't confuse you. Some people like to like shade in one of the p's so they know if it's uppercase or lowercase. But when we get to profit, that'll also be a p of x, and we just want to somehow differentiate the two. So p of x is equal to the price that the consumer pays per item. And then revenue we've talked about before. Remember, revenue just equals price times quantity. So R of x is equal to x times p of x. So quantity times price. And the revenue is just the amount collected from sales. So far, everything we've done is sort of on the demand side, right? It has to do with how many items were sold, what price we sold them for, and then like how much money came in as a result of those sales. We all know that it costs money to make money, right? To produce items, we have to spend some money. And so that's the other half of this whole thing, is that we have this cost, right? And so like as consumers, we sort of think of price and cost as the same thing, right? Like if the price of something is $20, it costs us $20. In this model, price and cost mean different things. So the price is the price that the consumer pays. It's like what's on the price tag. The cost, C of X, is going to be the cost to produce X items. So that is the cost to the manufacturer or the seller, as opposed to the price that the person pays to buy it. So the producer has to spend some money to make a product and then sells that product for a certain price, which isn't necessarily the same amount, or hopefully is not the same amount as it costs them to make it. The other thing to notice about cost and price is that C of X is a total cost to produce like 10 items, as opposed to the price is like one item, right? So the price is always the cost for just a single item, as opposed to when we talk about the cost of producing something, where like if I produce 100 items, then C of X is the cost of all 100. It's not the cost per item. Does that make sense, that difference between the two? And that's true of all of these. Like the only one that's a per item amount is the price. Everything else is like for the total of X items. And then the profit, well, the profit is just the net gain or loss that the producer experiences as a result of producing X items and then selling all of them. So profit, that's going to be big P of X, is equal to, so it's the amount of money that you bring in from selling the items minus the amount of money that you had to spend in order to make them. So revenue minus cost. And this is the net gain or loss from producing and selling X items. So these two sort of general formulas, this revenue, the profit equals revenue minus cost, I should put it actually over here. Profit equals revenue minus cost, and revenue equals quantity times price. Both of those are in like your little formula box. So if you look on your review, there's like a box at the very top that gives you some formulas for like the quadratic functions, and then also sort of these basic business formulas. So that'll be on the test. What's that?
That was my question.
Yes. So the box on your review, an exact copy of it will be at the top of your test. So always a good idea whenever you do one of these problems just to refer to that to make sure you didn't do something silly like add revenue and cost instead of subtract or what have you. Okay, so let's use all this. So one of the cool things about all of like this whole relationship is that once you figure out any quantity, you can figure out everything based on that quantity. So for instance, what we're about to do, like if I figure out what quantity will maximize revenue, I can figure out what price I should charge in order for that to happen, how much it's going to cost me to produce the items to make that happen, etc., because everything is based on quantity. So once you find out a quantity that's going to do one thing for you, you can figure out like what everything else is for that same quantity. So like I could figure out if I was maximizing revenue, I could figure out how much it costs me to produce the items, the number of items that will maximize revenue just by plugging that quantity into a different function. So that's why everything is based on the quantity, because then once you find the quantity that does something for you in one respect, you can make it work for all the other things. So that's sort of what we're working with, and this is the point where it becomes soup. I know you're sick of me saying it, but you gotta label everything. We've got 4 functions floating around here, all dealing with the same situation. So if you're not labeling things, it's gonna be really hard to figure out like what you found, what you're trying to find, what to use to find it, all that stuff. So just, you won't get marked down for over labeling, I promise. Like, just label everything in sight so that you can refer back to it, and every problem doesn't feel like a brand new problem because you've already set things up for yourself. So let's start just by writing down what they give us so I don't have to read through that paragraph every single time. So I'm going to start with my input. So X is going to be my quantity, i.e. the number of rugs that are produced and sold. They give me a bunch of information about the cost in that first sentence, which is basically just telling me how they came up with that cost function, right? So they say that the fixed cost is like $800. That's like your rent or whatever for your factory. And then to produce each rug, it costs $150. So altogether, the total cost is given by that function. So you don't really have to do anything with the information in that first sentence other than realize that it gives you that cost function. So the cost is given by C of X equals 150 X plus 800. And then we keep reading and we're like, okay, well, the price is given by, so this is our demand equation. P of X equals 400 minus 5X. So these are like the ones that we've been writing, like when we're given that table, right? We've written these functions that are like, okay, well, every time I increase the number of, or every time I lower the price by $5, it increases the number of items I can sell by 1, which is basically what that says. So now we want to find and simplify a revenue function. Remember, revenue is just price times quantity. So revenue, I always say price times quantity, but I feel like it makes more sense to think of it as quantity times price, because that's usually how we write it. Quantity times price. So that's R of X equals, so our quantity is always X, and then our price we get from our price function is 400 minus 5X. So that gives me R of X equals negative 5X squared plus 400X. So I'm just going to add that to my list. So then I want to know, what price should Montana Rugs charge if they wish to be able to sell 20 rugs each month? So whenever we do these problems, we want to ask ourselves, which function should I use? And what am I given, like an input and output, or am I trying to find like a vertex or x-intercept? So when I read what price, they're asking me for a price. So which function should I use? The price function, yes. I know it seems obvious, but you'd be surprised, like it's easy to get all this mixed up. So use the price function to find a price. And then, well, what information do they give us? We're not being asked to maximize or minimize anything. We are not being asked to like make anything 0. We're just being told how many rugs we're dealing with, right? So 20 rugs each month tells me that X is equal to 20. So this is just sort of a simple evaluation problem. They're telling me what my input is. We know what function we're using. We want to figure out what the output is. So we're evaluating lowercase p of 20. So I go to my list. I say I'm trying to find a price. That means I should use this function. And that gives me 300. So they can sell 20 rugs at a price of 300 each. As far as these sentences go, I'm not gonna like grade you based on the detail of your sentence, but I will warn you that like I said, there's so much going on in these problems that the more you can explain to yourself what the heck you just did, the easier it is to figure things out as you go. What's up, Chris? So I multiplied my quantity, which is X, times my price, which is given by the price function 400 minus 5X. So remember, in general, revenue equals price times quantity. So just do it really, really quick. Do like a quick flip. Go. Oh, that's pretty good.
I went all over my face.
Sorry. So the quantity is given by X right here. And then the price is given by P of X here. And so this is my quantity. And this is my price. So remember when we did those tables where we like had like quantity, price, and then revenue? Yeah. And we like wrote an equation for like the quantity or the price in terms of the quantity, and then we multiplied by X to get the revenue. That's exactly what we're doing here. We're just given that equation ahead of time. Does that help? Yeah. Okay. So yeah, you can always find the revenue function just by multiplying your input, which is X, by the price function, which is usually given in these cases. So this guy by this guy. You don't seem too sure.
Because you said multiply it by 5, so there's a 5x squared.
So we're multiplying it by x. So we're multiplying, so the price is 400 minus 5x, and then the quantity is just x. So maybe this would help. If where it says r of x equals x times 400 minus 5x, if I distribute that x, I get 400x minus 5x squared. Is that cool?
Yeah.
And then all I did was change the order
Okay.
of the terms. Was that
Yeah.
the thing? Okay. Okay, so then I wrote a sentence mostly just so I am aware of what exactly I'm doing here, and don't get myself mixed up about when to use 20 rugs and when to use 50 rugs and 40 rugs, because we're going to find all these different quantities and they all apply to different places on our graph, right? So I'm just labeling to keep myself sort of oriented as far as like what I'm finding and when I'm finding it and what it corresponds to. Like I said, it's easy to get mixed up here because there's sort of a lot of moving parts. So now we want to know what is the revenue. So when it asks what is the revenue, that tells me to use what? The revenue function. And then again, I'm just given an x value, right? I'm given a quantity. So I'm not trying to maximize or minimize or find x-intercepts, nothing like that. They're just straight up giving me an input. In this case, because we already figured out what the price is and we know what the quantity is, we could just multiply 20 times 300 here to get the revenue corresponding to an input of 20. You can also just go like straight mathematically from here and just plug it into the revenue function and you'll get the same thing. So
you plug in 20 for
yes.
5x. Okay.
So you'd plug 20 into your whole revenue function, and that'll give you the same thing, that'll give you 6,000. So either way you do it, like you can multiply 20 by 300. Like if you didn't have the price, like if you hadn't done part B and we just asked what's the revenue, probably the most efficient thing to do would be to just plug it into the revenue function. So the revenue from selling 20 rugs is 6,000. So far, so good? So let me just copy my big list here. No. There we go. No, we don't lose it. Okay, so now I want to know what number of rugs is going to maximize revenue. So this little tiny question actually gives me a ton of information about what it is I'm actually trying to find here. So it says what number of rugs. Well, that's a quantity. So that tells me that I'm finding an x value, and that my final answer will be the x value. So a lot of times, like, we find the vertex, and then we have to figure out, am I trying to figure out, like, do I want the x value of the vertex or the y value of the vertex? And it can be easy to forget, like, after you do all the work, which one you were trying to find. So it's a good idea to label it. Like when we do those projectile problems, and we're like, what's the maximum height? Well, that was a y value, right? You have to find the x value first, but then have to plug it back in. Here, we're not going to have to plug back into anything because we're asked for the x value. And then I see the word maximize, which tells me what? That I'm finding the vertex. Good. And then the fact that I'm maximizing revenue tells me to use R of X. So whatever it is that you're maximizing, that's the function, or minimizing, that's the function you have to find the vertex of. If I found the vertex of, like, the profit function, it's not going to tell me when revenue is maximized, right? So this tells me exactly what I have to do to solve this problem. Find the x value of the vertex of R of X. So I'm going to use my vertex formula, the x value of the vertex is given by negative b over 2a. So the x value of my vertex is going to be negative 400 over 2 times negative 5, which is 40. One thing to note here is that, like, you cannot find the vertex of a linear function. So you have to be kind of careful, like you can't just grab numbers from any old function and plug them into this like x equals negative b over 2a and be like, oh, that's the vertex. It has to actually be a quadratic function for this to happen. Because like if it's a linear function, it's like, whoa, it's a straight line, right? So like a linear function looks like this. It does not have a vertex, right? So even though I could take numbers from, say, the price function and I could plug them in for b and a, like it doesn't do anything it doesn't get me anything useful. Like that number doesn't mean much of anything because that vertex formula only works for quadratic functions. So be a little bit careful, like not to just throw numbers at something until you verify that you're actually using a function that like has a vertex, right? Before you use the vertex formula. So what this tells me is that selling 40 rugs will maximize profit. Oh, no, I'm sorry. Revenue, thank you. So, which is like a huge difference, right? We're going to get to the profit function here in a minute, but it seems to make sense that if you maximize revenue, you've also maximized profit. But like sort of the extreme example is, let's say that like I could maximize revenue if I sold like 100 items, but the factory that I have has a capacity to make 80 items. Well, in order to make 100 items, I have to get like a whole new factory that can make those extra 20 items, which incurs a huge cost, which makes my profit tank, right? So like even though I could make the most money from selling 100 items, that doesn't necessarily mean that I'm going to make the most profit by selling that many items because of the cost incurred from making like those extra however many items. So we can't make the assumption that maximizing profit and maximizing revenue is going to happen at the same time. So what we've learned so far is that if I sell 40 rugs, I'm going to maximize revenue. What that means is that now I have that quantity. And so anytime I'm asked about maximizing revenue, that's like telling me that the quantity is 40. So just like in part B, we were just given a quantity of 20. In part E here, if I want to know what price per rug I should charge to maximize revenue, well, the fact that I'm maximizing revenue now tells me that I am producing 40 rugs. Like that is now set in stone. Anything that has to do with maximizing revenue corresponds to an X value of 40. So like if you want to think of it graphically, like the revenue function looks like this. Stupid watermark is in the way. I'll put it over here. Or I'll just draw it over here. The revenue function looks like this. Or pretend that that's a really nice parabola that's all symmetric and such. And what I found was this point, 40. So now I have a price function also that looks something, it's linear. It looks something like this. Whoa. Actually, it's not going to go through. It's going to go like this, something like that. So when I find that 40, now we're saying that at this point on my price function, I have maximized revenue, right? Because I've kind of set that quantity in stone now because that's the only quantity that will make my revenue maximized. And so now I can look at what all the other functions do at that quantity and say, okay, this is the price I have to charge if I actually want to get a maximum revenue. So to do that, we are going to plug our quantity, which is now 40, into my price function. So I see that I want a price, so that tells me to use my price function. And I'm told that I'm maximizing revenue. That doesn't mean that I have to find an X value again. That tells me that my X value is 40 because we've already maximized the revenue, figured out that the only quantity that will do that is 40. So we're going to do P of 40, which is 400 minus 5 times 40, which is 200. So this seems a little bit weird, right? Like it seems like if I want to maximize revenue, I should just charge a whole bunch of money, right? Like the more you charge, the more you make. But we have to remember that demand relationship. So on this pink graph of my revenue, this point right here is like if I gave everything away for free, right? So like you could probably give away a whole bunch of rugs if you don't charge any money for them, but since you're not charging any money, you're not making any money. So your revenue is 0. And then lots of stuff happens, and this point over here, if I were to, so this point right here is like, well, I raised the price so high that nobody's going to buy any rugs. So even though I've raised the price really high so I can make a ton of money if I sell a rug, it's so high that I'm not selling any rugs. And so again, my revenue is 0. So like it's sort of, that's why it's a parabola, is it like your revenue increases as you raise the price, but then it decreases as you sell less items. So that's how that relationship kind of works, is like at either end, it's like free versus so expensive that nobody buys anything. So right in the middle is sort of that sweet spot. So, and we can kind of see like when we produce 20 rugs, we charge $300. So it seems like charging $300 should make us more money, but we were only able to sell 20 rugs at that price. So we made $6,000 as opposed to, in a minute, we'll find out how much money we made off of 40 rugs. So the price that will maximize revenue is $200. So these seem like individual functions, but they're really all interrelated, and that's because they're all based on the same quantity. So if price and quantity are related, and then quantity is related to revenue, then in the background there, that means that revenue and price are related as well. So now I want to find the maximum possible monthly revenue. What function should I use? The revenue function. And it's a maximum, which again tells me that X is 40. If I'm maximizing revenue, X is 40. So now I'm just plugging 40 in to my revenue function. And again, in this case, I already found the quantity and the price, so I could just multiply 40 times 200 to get my revenue. It'll give me the same thing as plugging it in, which is 8,000. So we can see here, even though we lowered the price from when we sold 20 rugs, it allowed us to sell more rugs, which gives us $8,000 instead of $6,000, which is what we got when we had a price of 300. So the maximum revenue is $8,000. So now we're going to think about profit. So now we're going to take into account the fact that it actually costs money to make rugs. So my profit, remember, is just the revenue that I bring in minus the cost that I had to spend to make them. So uppercase P of X is equal to the revenue minus the cost. And just like we've always done, since we're doing subtraction here, we're going to put each of those in brackets so we distribute correctly. So this gives me negative 5x squared plus 400x minus my cost function they gave me at the beginning, 150x plus 800. So then we have to think about getting rid of those brackets. Well, that first set of brackets on the left, I'm not multiplying by anything, so I can just drop those. And it doesn't do anything. But then in my second set of brackets, I have that subtraction to the left of the brackets, which means to drop them, I have to distribute that negative. So this is a negative 150x minus 800. So then if I combine like terms, I get that p of x is equal to negative 5x squared.
Wait, why is that 400 negative?
Oh, it's not. It's positive. Thank you. Plus 250x minus 800. And that's my profit function. So what you guys are going to do now is work with profit the same way we just worked with revenue. So what we found in the last few problems is that this is where revenue is maximized. Now we've come up with a second function. So this pink one is my revenue function. Now we've come up with this second function. We'll make it purple. It looks something like, I wish I could make these symmetric. I don't want that to go through that point. It looks something like this. And so it's going to have a different maximum, right? The vertex is not going to necessarily, I mean, theoretically it could, but in this case, the vertex isn't going to occur at the same place that the vertex of the revenue function occurred. So we're sort of starting from scratch again, and we're going to find, now we're going to find like where this quantity is and what happens there. So there's going to be a different price that will maximize profit because there's a different x value that causes where that vertex occurs because it's a different graph altogether. So I want you guys to try h through k. Essentially, h through k is exactly like b through f, except instead of using the revenue function, now we're using the profit function. So the process is exactly the same. We're sort of starting from scratch now with a new function and looking at all this stuff in terms of profit instead of in terms of revenue. Does that make sense? Okay, so go to it. Try h through k. Okay, so I've written down the calculations. Maybe you guys can tell me some of the numbers that I can't do it in my head. What's the profit earned from selling 20 rugs? 200. And then what's the profit earned from selling 25 rugs? That last one.
6,875.
Good. So our maximum profit is 6,875. Be a little careful here. Remember when we did revenue, we said once you find the quantity and the price, you can just multiply them to get the revenue. That's not true of profit, right? So we found that you would have to sell 25 rugs to maximize profit at a price of 275. That 275 is right? Okay. At a price of 275, multiplying 25 by 275 is not going to give you your maximum profit, right?
Well,
It'll give you.
That's not the max profit, because that's what I did.
Oh, then that's what you did. Oh, then what you found is the revenue that you would earn to maximize profit. So
I have to plug it into that.
yeah,
profit.
because the only thing you get by multiplying price times quantity is the revenue. Right? You don't get so the process isn't quite the same. What's up, Chris? Were you just going to say that's not the right number?
I got different.
What is it?
2325.
Okay, good. Because remember that profit takes into account the revenue, which is price times quantity, and the cost that it took. So the key to all of these, you guys, probably every single one of these questions, you can wrap your head around by asking yourself if you're trying to find, so like, do I want an X value? Or a Y value? Am I finding the vertex, the x-intercepts, or just some point? Right, so this would be if you see like max or min. This would be like if you're told that the output is 0. And this would be like if you're just given some input. Right, so like the first ones we did, they just told us there were 20 rugs. That would be like the third one. Whereas when we were asked to maximize something, that would be like I'm finding the vertex. And then the last thing you always want to ask yourself is, what function should I use? And I mean, like, that's one of those things where, like, when we first ask what function should I use to find the price, like, everybody giggles because it's like, well, you should use the price function, obviously, lady. But as we sort of get deep into this, it doesn't feel quite as obvious because there's, like I said, so many moving parts. And first we're finding revenue, then we're finding price, then we're finding profit, right? There's, like, a lot of different things. So, like, try to explicitly ask yourself, like, what function do I actually need here to get what I want? Just asking yourself those questions, like, really deliberately is gonna help you get where you're trying to go. Because all of these things are things that you guys answer perfectly when I ask them to you. And I think that the problem that happens, like, on tests or homework is mostly just that you kind of, like, go on autopilot and start throwing numbers at things without really thinking through all these pieces that we think through in class. So it's all stuff that you guys know the answers to. Just make yourself slow down to actually ask the questions so that you get to those right answers. And try not to go on autopilot. That's going to be, like, the key to all of this. Okay, let me give you some homework.